Okay, only 67 students are there. Please, you have to inform to the others also. They will also join the class. We'll wait for another 2 to 3 minutes and then we'll start with new chapter, Micromeretics.
Excuse me, sir.
Sir, you are not audible.
Sir, actually, your mic is off.
Sorry. Yeah. Uh, Now, yeah, am I audible?
Yes, sir.
Then the different properties we are going to determine in this heading, because these are the contents. First, we are going to discussion on particle size and size distribution. Then second one is the mean particle size and its distribution. Then the particle distribution with respect to the number and with respect to the weight, and then particle number calculation. Then methods which is used for determination of particle size, like sieving method, segmentation method. Then optical microscopic methods are used, and then the particle volume is going to be calculated by using the Coulter counter method which is used. And afterwards, the methods which is particularly used for determination of its surface area, like surface area is going to be determined by using air adsorption method and air permeability method. Two methods were used for determination of its surface area. Then the fundamental and derived properties. In fundamental, particularly, we are going to focus on the particle size and its distribution, the particle shape, surface area, volume, and number of the particles. And in derived properties, we are going to focus on these densities, different type of the densities, granule density, then bulk density, then specific density, then relative densities, then true density. We are going to determine here, and then angle of repose powder sample, and then again relationship between the angle of repose with respect to its the relationship with its flow properties of the drug molecule, then again Hausner ratio and their relationship with the flow properties of the powder molecules, and then packaging arrangement of the powder, how the powder is going to be arranged in rhombohedral or whether it is closely packed to each other. That part we are going to discussing in this micromeretics chapter. With this content, we'll move towards the next point. We'll start with the first particle size, because particle size is it plays an important role in case of an pharmaceutical formulation or in formulation of any drug or converting of any drug into the form of an dosage forms, because the drug absorption and drug bioavailability of the drug is depends on the size of the drug molecules. There is a relationship between size and shape and surface area of the particles. If the particle size are smaller, then it cover more and more surface area, then the solubility of the drug is going to be increased. And if the particle size it is less, then the surface area of the molecule is also going to be uh, it cover the less surface area. And if it cover the less surface area means there is chances to to less solubility of the drug, and that drug is unable to give it its optimum bioavailability. The bioavailability and drug absorption, the two different terms are there. The drug absorption means what? The rate and extent amount of drug which reaches to the systemic circulation. It is called as the rate and extent amount of drug which reaches to the systemic circulation. It is called as drug bioavailability. And the unchanged drug which reaches to the systemic circulation is called as the is called as drug. In case of an unchanged drug, and in case of an viability, it is changed drug which reaches to the systemic circulation. And it depends on what? It depends on the size of the drug particles. If the particles are
Sir, your voice is not clear.
and
Sir,
that's
your
why the
voice is
solubility
not
is
clearly
also
audible.
enhanced particles. Yeah, it depends on the size of the drug molecules. And what are those particle size? Suppose if the particle size ranges from 5 to 10 micrometer size range, particularly when we are talking about the different type of the drug in disperse system. Disperse system like colloidal dispersion or coarse dispersion type of the drug, coarse dispersion type of the system, particularly in suspension and emulsion. The particle size range between 5 to 50 micrometer size range particles are there. And if the particle size in between 5 to 10, then it is in the form of an suspension and emulsion. If it is coarse emulsion particles or flocculated emulsion particles, then the size range is in between 10 to 50, and 50 to 100 micrometer size range particles in fine powder ranges. And the coarse powder range 150 to 1000 micrometer size range particles, and average granule size it is in between 1000 to 3660 micrometer size range particles. Afterwards, we are getting the data when the particle size, if we know the particle size, and then go for calculation of its percent frequency. And according to the percent frequency, we are going to calculate how the particles are going to be distributed, whether it is distributed in uniformly or the polydispersed type of the distribution we are getting into the dosage form. That part we have to analyze it, because all the pharmaceutical powders are dispersed in polydispersion type of the distribution. And if the particle size and if the distribution of the particles with respect to the number, then that type of the distribution, it is called as the number distribution. And if the particle size of the drug molecule with respect to its weight, then that type of the dispersion, it is called as weight distribution of the particle. Now here you have to see this type of the graph, it appears when with respect to the number or its respect to its volume of the particles. And if the particles are distributed with respect to its frequency, frequency means what? The total number of the particles which is distributed. How the total number of the particles we have to count it by microscopically, we have to count the number of the particles are in between the different size ranges. Suppose if the particle size range it is in between 0 to 10 micrometer size range, then you have to count the total number of particles, how many number of particles it is in between 10 to 20, or 20 to 30, 30 to 40 micrometer size range, up to 100 micrometer size range particles. You have to count it and then individually then take its frequency, the number of frequency of the particles, and plot the graph with respect to the frequency versus the particle size versus the frequency of the particles, and then we'll get this type of the graph. And this graph, it is called as frequency distribution graph. Okay, frequency distribution graph. And here you have to see the graphs. We are getting the different type of the graphs, and these graphs are shown clearly indicates that the pharmaceutical powders are not dispersed in uniformly sized distribution we are getting for the pharmaceutical powder sample. Then afterwards, we'll start with this micromeritics. The micromeritics term, J.M. Dalavali has defined the terms like micromeritics. It is a science in deals with study of the small size particles. Small size particles. Why small size particles? Because the particle size is measured in micrometer size range or micron size, or it is equal to the 10 to the power minus 6 millimeter size range particles. Then micromeritics is also defined as the study involves the fundamental and derived properties of the powder sample, or fundamental and derived properties of individual powder sample, as well as the collection of particles. It is called as micromeritics. Then micromeritics is the science and technology of small particles, and by using this knowledge, and the control size and size ranges of the particles are significant important in the field of pharmacy, because there is a relationship with what? There is a relationship with the size and surface area of the particles, which is related to its physical, which is related to its chemical and pharmacological properties of the drug molecules. all the physicochemical properties and pharmacological properties of the drug molecule, which depends on the size and size range of the particles. This size range, it plays a important role in case of the formulation of the drug molecules, and also the size, it plays an important role in drug development stages. Afterwards, the particle size of a drug can be affect its release pattern. The release of the drug is also depend on the size range of the particles. The release pattern of the drug is also basically depends on the size of the particles, because particularly the release of the drug, with respect to its oral drug administration, or parenterally, or rectally, or topically drug delivery system. If you want to give the drug by using any route like oral, parental, rectal, or topical route, then you have to think about its size of the particles. In collection of the particles of more size, one size or two properties are mostly important properties, like one is the shape and surface area of the individual particles, and second one is the particle size and size distribution, the size range and number, the size range of the particles, whether it with respect to the number or with respect to the uh, weight of the particular powder particles. It also depends on what, it also depends on the size and shape of the drug molecules. Then the different applications of this micromeritics in the field of pharmacy. First one, the release rate and the dissolution rate of the drug is depends on its size range of the particles, because particle size and surface area release the drug in release of the drug in dosage forms. High surface area, it allows the intimate contact of the drug with the dissolution fluids in in vivo, and increases the solubility of the drug molecules. And once the solubility it is enhanced, then automatically the dissolution rate of the drug is also going to be increased. In case of absorption of the drug molecule, in absorption means, already we know, the rate and extent amount of drug which reaches to the systemic circulation is called as drug absorption. Particle size and surface area influences the drug absorption,
Sir, your voice is not clear.
its therapeutic action. The particle size is sorry. Hello. Yes, am I
Sir,
Sir,
you're
your
audible?
not
voice is not
audible
clear.
properly.
Due to connectivity, due to internet problem is there. Maybe it arises due to the internet. Please wait. Yeah. Am I clearly? Yes, students. Hello. Yes. Am I audible?
Yes, sir.
Yes, sir.
Yeah. Okay. Then the size, it also plays an important role in dose uniformity of the drug molecule. The uniformity of the dose is also depend on the size range of the particles. Good flow properties of the granules and powders are uh, are important in the manufacturing of the tablet and important in the manufacturing of capsules, dosage forms. Now these are the different applications of this. These are the different applications of this particle size or micromeritics in the field of pharmacy. Then we'll move towards the next point, the particle characteristics. What are those fundamental properties for the drug molecules? Okay, what are those fundamental properties? First one is the particle size and size distribution. Second one is the particle shape and surface area. Third one, particle volume, and last one is the particle number. Yes, students, is it clear? Have you understood what do we mean by micromeritics? Yes, please. Anyone can define the micromeritics. What do you mean by
Science and technology of small
micromeritics?
particles.
Yes, micromeritics is the science and technology of the small particles. Okay, the next. Yes, students. Next definition. Micromeritics. It is the branch of science in deals with study of some fundamental and derived properties of the powder molecules. Fundamental and derived properties. What are those fundamental properties? Yes, fundamental properties. Fundamental properties. First one is the size. Second one is the shape. Third one is the surface area. Fourth one is the particle volume. And last one is the particle number. What are those fundamental properties? Yes, please you have to repeat it.
Size,
Yes.
shape, particle size,
Okay. Hmm?
Surface area.
Parti surface area. Then particle number and particle volume. Okay. Then in derived properties, what are those derived properties? In derived properties, first one is the in derived properties. First one, densities, different type of the densities of the drug molecule. What are those densities? Tab density, bulk density, granule density, then true density, then angle of repose. After angle of repose, the next property is the car compressibility index, then Hausner ratio, and bulkiness and flow rate of the powder or flow rate of the granules. These are called as the different derived properties for the powder sample. Then the particle size and its distribution. We'll move towards the next point. The particle size and its distribution. If the size, if the shape of the particle is perfectly spherical in shape, then the particle size is measured by particle size is measured in its diameter, by its diameter. But the particle become a more asymmetrical in nature, then there is a difficulty in expressing its size. If the particle size are perfectly spherical in shape, then it is possible to determine its size in the diameter. And if the particles are asymmetric in nature, then it is very difficult to express the particle size in its diameter. Such conditions, there is no any single diameter of the particles we have to observe. In some cases, use the equivalent diameters which is used, which is related to the size of asymmetric type of the particles, or the diameter of the sphere having the same diameter and its area, or with respect to its volume of the particles. And what are those different types of these diameters which is used for determination of asymmetric type of the particles or asymmetric size of the particle is going to be determined by using the various types of equivalent diameters. And what are those equivalent diameters? First one is the surface diameter. Second one is the volume diameter. Third one is the projected diameter. Fourth one is the Stokes diameter. Fifth one is the sieve diameter. And sixth one is the surface volume surface diameter. Yes, am I audible clearly? Yes, students.
Yes, sir.
Yes,
Okay.
sir. Yes.
Uh, yeah, yeah. So, here, first thing you have to clear in your mind if the particles are perfectly spherical in shape. Okay, spherical in shape means what? If the particles are perfectly spherical in nature, here I will show you the particle size, how to measure the particle size uh, with the symmetric particles and asymmetric type of the particles. Okay. For example, here you have to see if the particles are perfectly spherical in shape, then please wait. Here I will show you. Yeah, suppose if this is the particle, yeah, you have to observe this is the particle, and now this particle it is perfectly spherical in shape, right? Now this is the particle, it is perfectly spherical in shape, and okay, and if the particles it is the particle it is in perfectly spherical in shape, then you have to go for determination of its diameter. See, this is called as the diameter, right? This is the diameter of the particle, and if this is the diameter of the particle, yeah, here also, see, now you have to measure this point, point A to point B or point C to point D. Then this is the total whatever the value you have to measure it, and it is in the form of what? It is in the form of the diameter for this particle. And now this is the diameter for the spherical particles. And it is possible when the particle is perfectly in spherical in nature. And if the particles are not perfectly in spherical in shape, but it is asymmetric in nature. Asymmetric in nature means what? Asymmetric type of the particles. Asymmetric means, yes, students, what do you mean by symmetric and what do you mean by asymmetric? Yeah,
In our symmetry, we cannot divide into two parts. And symmetry, we
yes,
can divide in two parts.
yes. Whether it is divided in two types or not. Say, for example, here it is a type of the particle, and here B type of the particles. Okay. Uh, which one is the symmetric and which one is asymmetric? Yes, please tell me.
A is symmetric,
Asymmetric
B is
and B
unsymmetric.
is
A is
asymmetric.
symmetry.
Yes. A is symmetric and B particle it is asymmetric in nature. Why B is asymmetric? Because in case of an A, we are going to consider uh, if it is in case of A type of the particles, we are going to consider its equivalent diameters. If it is A, then we are going to measure the diameter of the particle. Uh, Diameter of the particle easily. It is possible to measure with the help of the scale. And if it is a asymmetric type of the particle, then it is difficult to measure its yeah, difficult to measure its dimensions. And during that time, we have to take its equivalent diameter, whether the equivalent diameter is equal to its area or the diameter which is equal to its surface area or the diameter which is equal to its volume of the particles. Okay, that's why the diameters are divided into different types of the diameter. Like first diameter is called as the surface diameter with respect to its surface of the particle, with respect to its volume of the particle, with respect to its projected means how much area is going to be focused under the microscopic area, or with the help of Stokes diameter. It depends on the rate of settling of the particles, or depends on the mass aperture size, the sieve aperture, whatever the sieve aperture we are using, depend on that size. We are going to conclude the diameter of the particles or the surface, volume surface of the particles. Now there are different six types of equivalent diameters. First one is called as surface diameter, DS. Surface diameter, it is defined as the diameter of sphere having the same surface area as that of symmetric particles is called as surface diameter. Once again, uh, yeah, I'm going to repeat the same definition. Surface diameter, it is defined as the diameter of sphere having the same surface area as that of the symmetric asymmetric particle is called as surface diameter. Volume diameter, volume diameter is defined as the diameter of the sphere having the same volume as that of a symmetric particle is called as volume diameter. Third diameter, projected diameter. The diameter of the sphere having the same observed area under the microscope as that of a symmetric particle is called as projected diameter. Stokes diameter. Stokes diameter is defined as the diameter which describes an equivalent sphere undergoing the sedimentation at the same rate of asymmetric particles is called as Stokes diameter. Sieve diameter. The diameter of the sphere having the same sieve aperture as the symmetric particles is called as sieve diameter. The next diameter, the volume diameter of the particle, is the diameter of the sphere that has the same volume to the surface area ratio of a symmetric particle is called as the surface volume diameter. All these diameters are possible when the particles are distributed in case of asymmetric in nature. If the particle it is in symmetric nature, then it is possible to measure its size of this particle is going to be measured with the help of the diameter. And if it is asymmetric, then we are going to measure the different type of the equivalent diameters like surface diameter, then volume diameter, then projected diameter, and Stokes diameter, then sieve diameter, and volume surface diameter. Yes, students. Now tell me, if the particle is spherical, then which type of the diameter we are going to measure? Yes.
Sphere diameter. Surface diameter.
Yes.
Surface
Yes,
diameter.
if the particle is spherical, then it is possible to measure the surface diameter of the particles. And if the particles are asymmetric in nature, asymmetric means unequivalent, the points, then which type of the diameters we are going to measure in case of asymmetric type of the particles? Yes.
Volume
What are
diameter.
those?
Projected diameter.
Yes. See, please here you have to uh, read the same six type of the diameters. One, surface diameter. Second one, Yes, students.
volume diameter,
Volume diameter. Third one,
projected diameter,
Projected
projected
diameter.
diameter. Yes. Then
Stroke diameter.
Stroke diameter.
stroke diameter. The next,
Sieve
Sieve
diameter.
diameter.
sieve
diameter,
diameter. And last one is the
Volume surface
Surface
diameter.
diameter.
volume
yes.
surface diameter,
All these diameters are measured when we are going to
Particle.
measure this equivalent diameters.
Asymmetric party.
Yes, for the
Particles, right?
asymmetric type of the particles. Asymmetric, then we are going to measure the different type of the diameters. Yes, this point it is clear now. Yes, have you understood this point? In particle size, if the particle size are spherical, then we are going to measure its surface diameter. It is easily expressed in the diameter. And if the particle is asymmetric, then it is difficult to expressing its size. In such conditions, we are going to measure the different type of its asymmetric type of the surface diameters we are going to measure, and that surface diameters are with related to its diameter, or which related to its area, and which related to its surface area and volume of the particles. Therefore, we are going to measure all these six type of the diameters. One is the surface diameter, second one is the volume diameter, third one is the projected diameter, next one is the Stokes diameter, then sieve diameter, and volume surface diameter. Yes, students. Now these points are very, very important for the GPAT point of view. If the particles are asymmetric in nature, then what type of the diameters are going to be determined with respect to its volume, with respect to its rate of sedimentation, yes, with respect to its volume diameter of the particles. Okay. Then also you have to note down these points because this is the important point for GPAT point of view. What are the fundamental properties for the powders? Yes, now tell me, what are the fundamental properties for the powders? Yes, students.
Size, shape,
Very good.
particle size,
Safe.
volume,
surface area, particle number, particle volume.
Size, shape, surface area, and
Particle number.
size,
particle
shape,
number
volume,
and
and
particle.
number of the particles. Yes, very good. And what about the derived properties? Derived
Densities,
properties. Yes. What are
granular
the
density,
uh, granule density, tab density, bulk density, true density? Okay. Then angle of repose. Then second one is the car compressibility index, then flow rate, then bulkiness, then Hausner's ratio. All these are the derived properties for the powder sample. Okay. Now note down two questions. You have to note down the two questions. Write down first question. Simultaneously, also you have to start writing on this micromeritics point. Then first question, write down define micromeritics. Write down first question. Define. Okay. Also, simultaneously, I will start chatting in the chat box. You have to write the questions. Write down the questions. Define the term micromeritics. Define the terms micromeritics and give its application. Give its applications in pharmacy. This is the first question. Then write down second question. what are the fundamental and derived properties of powders? What are the fundamental and derived properties of the powders?
Sir, shall we explain it in detail?
Yes. Then write down next question. Yeah. You have written two questions. First one is the define the term micromeretics, give its application in pharmacy. Then second question. What is second question? Yes.
What are the fundamental and derived properties of powders?
Yes. What are the fundamental and derived properties of the powders? Then write down third question. Explain different types of explain the different types of equivalent diameters for asymmetric particles. Okay. Please, what you have to do, you have to make a separate notebook for physical pharmaceutics 2, in which day to day you have to write the answers of these questions. Okay, if the class it is over, then simultaneously you have to write the answers. First question, define the term micromeretics, give its application in pharmacy. Then second question, what are the fundamental and derived properties of the powders? And third question, explain the different types of equivalent diameters for the asymmetric type of the particles. Okay, students. Okay. Then uh, here I'll stop the session over here. Then in next class